Okay, so this is number 11 on 2023 AMC. So the rover was launched on July 30th on 2020. Okay, after traveling this many miles, it's landed on Mars on 6.5 miles. So which are the following closest to the average speed? So this is like basically rate problem. So we just like to probably start with distance is equal to rate times time. Okay, so we want to find the speed. So we can just divide both side by time to get my rate. So then rate will be I can just go ahead and run this number, I guess, because we have the choices. They are not really too close to each other. So we have a kind of luxury to run this a bit easily. So that would be 300. And then adding 6 zeros is okay, but I'm going to write 300 times 10 to the 6th power and divided by 6.5 months. But we know we are looking for average like as miles per hour. So 6.5 miles, I mean month. Okay, I can multiply this by like 30 days because every month average like has like 30 days, so maybe 31, but I can go with this one because it's easier to divide by 30 instead of 31. And then each month, like, I mean, each day has like 24 hours, but I don't want to make 24, so I'm going to make actually 25. So here's what happened. This was 292. It wasn't 300. So I just made this numerator a bit bigger than what actually I have. But at the same time, I just made this number a bit bigger than what I actually have as well, because this has to be 24. And so I just made it a bit bigger, and then I just made this a bit bigger. So my actual like approximation didn't really change that much. Okay. So which is why I can actually deal with this. So now, I can cancel 1 zeros. Actually, I can divide by 3 as well. So that's going to be 10 times 10 to this 6th power. And you may go ahead and simplify this a bit. Maybe I should have canceled one of the zeros because it's multiplying like 6.5 by 10 is much better. So anyway, so I can maybe put those backwards. So you can do this as well, but I'm going to put it back. So what I'm trying to do now, instead of just canceling, I'm going to multiply 6.5 by 10, which is 65, right? And then this is going to be just 3. So I can cancel those. So that should be 100. So these guys will cancel. You got just 4. So let me write actually one more time. So 4 times 10 to the 6 over 65, right? Okay, so now you can actually see, like I can take maybe some another tens from this guy, so we can cancel with like 65. So that would be 4 times 10 times 10 to the 5th power over 65. So I can divide by 5, which is 2, divide by 5, which is 13. So, if you take one of like this 13, like if you round this to the 10, okay, so that means we'll cancel one of those 10s. That will be 10 to the 4th power, which is 10,000. So that will be 8 times 10,000, so 80,000. So that looks like close to what I'm looking for. But at the same time, I made this number smaller, which means my number actually was going to be a bit smaller than 80,000. So which is actually much like clear to see. This is actually going to be my approximation. Okay, but this is something you can try. Maybe there are some other ways you can like discover as well. But what I just done, my last step was instead of 13, I just made like this 10. Since my numerator is actually getting smaller, so my number like is gonna be getting bigger than what actually I should have. So if this is 10, then this is gonna be 8 times like 100, like 100,000, right? Because that will be 5 zeros after 1. So that is like one of those zeros will cancel. You get just like 10,000 times 8, which is going to be 80,000. But that is a number that should be a bit larger than what we should be getting, because I made this number smaller. Instead of 13, I just made it 10. So that's why 60,000 is actually the best approximation, because this is too small. This is just like, as you see, 5 times as small, which is something we don't really have in our division. So that's why it's just our answer is C. Okay. So I hope that makes sense.